In section 2.3, we're going to add to our equation solving strategies by talking about how to deal with decimals in equations. One thing you can do when dealing with equations with decimals is simply accept the fact that there are decimals in there and that you might have to focus a little bit more when you're doing calculations. They might be a little bit more difficult, but they don't change any of the concepts of solving equations. So here we would simplify first, multiply through to get rid of the parentheses. So we would be left with 0.92 plus 0.9x minus 0.9 times 0.3 is 0.27. That's where I might see some mistakes where people have, 0.027 or 2.7 or some error in the decimal calculations. But if you can handle that, nothing is different about the calculations themselves. You can combine like terms. We got 0.92 and minus 0.27, so we can combine those like terms to, what does that be, 0.65. And then we can use our addition property of equality to do opposites to cancel out some stuff. So if we're adding 0.065 on both sides to cancel those out, we're left with, let's see here, 0.53 or 5.3. Take away 2x on both sides. Remember, we're showing all this work still because this is the point of the problem. Can we solve this equation? We're taking away that, so that should be negative. Dividing by this decimal is going to be the extra challenge, especially if you are not allowed a calculator for some reason. And I do have a calculator here, and this is approximately 4.818, and the decimals continue on. So like we just saw, one of the strategies for solving equations with decimals is you could just deal with the arithmetic of the decimals, right? Just go forward, be careful, and none of the concepts of equation solving has changed. However, if you don't have a calculator, it might be easier to get rid of the decimals, so to say, by doing the same thing to both sides in a way such that the decimals are cleared. And what we know about multiplying by 10 is that it just continues to shift the decimal over. If we multiply by enough factors of 10 such that all of the decimals in the problem move over far enough that we don't need to write them anymore, then maybe we can be more confident in our calculations, and in the end you'll see maybe have a fractional version of the answer where we don't have to adjust decimal fractions to simplify. So here we see the same equation that we saw before, but this time we're going to see how it would look if we tried to get rid of some of these decimals by multiplying by an appropriate power of 10. So we see 2 decimals here and we see 2 decimals here, so maybe if we multiply by 100, that'll be enough to get rid of those decimals. So let's try that. We're going to multiply by 100 on both sides. 100, 100. This might look unique in terms of equation solving because it's not like we're multiplying by 100 to get rid of a dividing by a 100 that we're staring at, but that is what's going on inside these decimals, because that's like 92 over 100. So it is there sort of behind the scenes. So we're going to multiply both of these. That's going to give us 92. I'm going to skip over this for just a moment. And then this one is 200x, and this one is 595. Okay? The reason I skipped over the middle one is I can show you a little something interesting. Let's see here. I'm going to have you think about something quick that is just off to the side. Let's say I asked you to do 6 times 4 times 5. So if I asked you to do that in your head, 6 times 4 would be 24 times 5, and so that would be what, 120? Or you could think about it as the 5 times 4 first if you wanted to give you 20. Okay, and then 6 times 20 is 120. Hooray. What I want to bring up here is, let's say we thought about it as this, and then we went through and said, well, 6 is 2 times 3. What I want us to understand here is that if we were going to break these up into smaller multiplications, we don't multiply one of these times this and this, right? There's no distributive property like that when this is also a product. It's just all of the things are getting multiplied. So why do I bring that up here? I bring that up here because we're multiplying 100 times this expression right here, and that has itself two different factors, right? Two different parts. And the 100 that we're multiplying by has two factors of 10 in it that we chose because we needed two factors in there. We needed to move the decimal spot twice, but we don't need to move the decimal spot twice in either of those. So rather than multiplying 9 times 100 and then distributing inside and still having to deal with that decimal, let's think about the 100 as being 10 times 10 and using this 10 to multiply this chunk and this 10 to multiply this chunk, and just sort of be creative in our application of multiplying that number. That would make both of those decimals go away in sort of one step, and is just a flexible way of thinking about how we're multiplying by 100 in this case. Just wanted to expose you to a different way of thinking about that. So if we continue on and distribute and then collect our like terms, we're maybe a little bit more confident now in our calculations when they don't involve decimals. But maybe more importantly than that is when we get down to this end result, we're left with something that we can see as a fraction and maybe be a little less nervous or a little less anxious about staring at dividing by 1.1 like we saw in the last one. So we're left with negative 110x, so divide by 110 or negative 110, okay, and we're left with x equals negative 530 over negative 110, but we know a negative divided by a negative is a positive, and we know that these factors of 10s would cancel out, and so we can pretty easily reduce this, and this ends up being the same as the decimal that we saw in the end of the last problem, but fractions, reduced fractions in this case, because 11 is prime, is always preferred to rounding or truncating a decimal.